Hi guys, good evening everyone. Today I'm going to present a brief discussion and analysis on quantum key distribution. Let me share the screen. Okay. Okay. Yes. Okay. Right. So, good evening everyone again. Today I'm going to present a brief discussion and analysis on quantum key distribution protocol BB84, which is used in quantum information communication. Okay. The protocol is part of various quantum key distribution protocols. Part of this presentation is to give you idea as a part of presentation the part of presentation is to give you idea about the fundamentals of quantum communication, like typically seeing how Alice and Bob agrees upon a key using this baby 84 protocol. Okay, so in initial slides I will touch upon the basics that Aditya started yesterday, and thanks to him that I can move my starting slides fast. After basics I will give you a quick history, uh, how it all started and why quantum is necessary. Okay, I mean why quantum communication is necessary and why quantum key distribution is a way to achieve quantum communication. Moving to second part, I will thoroughly describe the BB84 protocol. Like you need to understand this so that you can understand my claims and work in later parts of the presentation. In top view, my work is somewhat addition to BB84 protocol in the same sense of attacking the protocol and analysis of quantum advantage to Alice and Bob. Okay, so yeah, and analysis. I will also present analysis attacking advantage of the eavesdropper. Then I will present my work as a code demo which I implemented using Google Colab, using Qiskit library that is from IBM, and I have written somewhat around 109 lines of code. I know this is not much, but I will improve it and add new functionalities by adding component of eavesdropper. Currently, the code is set up with the environment only with respect to Alice and Bob, assuming no Eve. Okay, so let's begin. So before we go ahead, I want you all to need to understand that a professor in Alto University claimed that by 10 years or later, our existing systems will not be safe. In the sense that whatever data is encrypted from I mean whatever data we have in encrypted form that reside with security agencies can decrypt it. That is, without quantum safe encryption, everything we have ever transmitted over network or will ever transmit over a network is vulnerable, because of course what governments are doing is like they are dumping encrypted information now, and when a quantum computer comes along they will able to decrypt it. And that now if that's so now if that's information that is the information which has transient value, that is not a problem today. But what if you are in I mean, what if you are in its information, okay, which has I mean information with a value of 10 years? That means that if a quantum computer is available in 2050, you need to be quantum safe in 2040. Okay, what if it's your DNA information that can be used against you and your children? What if it's military information that should be kept secure for 50 years? Right, so this is a challenge we need to encounter. So yeah, so as we have already covered this, just for the sake of completion, I will quickly go through the elementary build-up. So fundamentally, there exists a probabilistic bit. Recall that we are calling it as a probabilistic bit, and recall that classical bit is deterministic, right? So this is non-determin. This is where the non-determinism arises in the quantum system. So the qubit is represented as block sphere. Block sphere can be assumed as a Hilbert space or multi-dimensional space where the value of qubit reside. For the ease, researchers have tried to make this easy to communicate with non-STEM people, basically non-science and technology, engineering, mathematics people. And one qubit is asserted as alpha times quantum zero and beta times quantum one, which is shown in the slide. Okay, so yeah, so essentially, block sphere tells you about the various spins and excitation of the quantum particle, and we don't require to go much deep inside the fundamentals of chemistry and physics, not required for the sake of quantum cryptography. And just assume block sphere is a kind of representation to tell a qubit is a superposition of values until observed. Okay. Yeah. So okay, so as we saw yesterday about quantum gates, I will quickly go through each of the quantum gates so that we can quickly jump on the analysis part of VB84 protocol. And there are like four to five quantum gates, namely identity gate. So identity gate does not result any changes to the quantum bits. So imagine imagine it as a imagine quantum gates as a as a gate which is classic, I mean equivalent to classical gate. And just they take input as a quantum bit and results in quantum bit. Okay. I mean results in a new quantum state. So so here identity gate will not result any changes, that is takes 0 qubit as input and result 0 qubit as output. Second is Hadamard gate, takes one bit as input and converts that to a superposition. Right, takes one bit as input and converts that to superposition. Creates a quantum superposition states when applied to quantum basis states. That is, like it creates a superposition. You enter the qubit and it produces the superposition of the two states of the quantum particle. Okay. So NOT gate is a basic which is equivalent to classical NOT, that is also called as poly X. And there are other two gates which we can skip for now, because we mainly need NOT gate and poly X gate and Hadamard gate for our understanding in later part of the presentation. Okay. So I would like to brief more about the Hadamard gate. Yeah, I would like to brief more about Hadamard gate, as this is very important for the sake of our protocol. We will learn in the later part of the presentation. So basically, it transforms one state of a qubit to another. In some words, if the qubit is deterministic state, that is 0 or 1, it will transform the qubit to plus or minus respectively, and vice versa. It will give more clear information. I mean, it will get clear when I will present the slides. Okay, I mean when I will present the notes. Uh, when I will present it on the notes in my iPad. Okay. Yeah. So this is just the representation qubits in a two qubit quantum system. You can appreciate that 0 0 and 1 0 are deterministic, but 0 1 and 1 1 are non-deterministic, are actually superposition of both the states. So basically, this is a two qubit system, where the qubit is realized with uh, basically input was 2 qubit but output was a single qubit, and it was realized using a poly-X gate and a Hadamard gate. Don't worry if you are not getting it, because it will clear if when I will be presenting my screen from notepad. Okay. Okay. Yes, I will quickly cover you tell you about the quantum cryptography and why quantum key distribution is necessary here. And so before that, I will give you a quick history to quantum information computing. So it started with Feynman, that is Richard Feynman in 1970, and then several developments started along the decades. Physicists had gained control over one photon quantum system. So sorry, sorry. Yes. So it started exploring the behavior of the photons and other subatomic particles. Researchers realized that with only few qubits, that is, only few qubit quantum systems are able to outperform the complex calculations, right? So this was the starting of the quantum computing theoretically. And yes, here I will tell you about why quantum cryptography, what is quantum key distribution. So it would be possible for crypto analysts to use regularities to decipher the message. So when a message, when a message, as long as the key has been sent, the key must be renewed. Okay. So it's like Alice and Bob are two protagonists, and you start the communication between the two. Before that, you need to have a secret key in classical cryptography, right? So this is the counterpart, that is the this is the alternative for key distribution, basically, to make it more secure. secure, because quantum particles behave or exist in such a way that you exploit the features of properties of the quantum particles. And the fundamental idea of quantum key distribution is that after sharing the key over quantum channel, Alice and Bob can make a test, okay, to check that nobody has been able to eavesdrop, because this exchange of key must be absolutely secure. It turns out that a quantum technology can be used to solve that the problem of secure key sharing. And Alice and Bob need to obtain a new pair of identical encoding decoding keys. Yes, but if the test is passed, they have a new key that can be used whenever they want. The fundamental reason when quantum physics ensures that the security of the key distribution is that any measurement on individual quantum object or quantum particle leaves a trace, a footprint. In other words, in simpler words, it is impossible for eavesdropper to read the information written on the quantum bit without perturbing it. So this perturbation is actually detectable. Okay, and yes. So basically, classical cryptography is a different thing, and this quantum cryptography is a different thing. Leverage properties of this quantum particle such that eavesdropper is detected easily in very early stages of the communication, and you can actually tell that the line is secure or not in just few trials. Okay. Yes. So now I will tell you about the BB84 protocol, in which I have done some work also. And yes, first I will tell you about the BB84 protocol, and then we will discuss about the work what I have done, and what I will be presenting in I mean in later parts of the presentation. So, BB84 protocol, before I start describing with Notepad, let me give you a small idea about it, the process, how it works. So there are two protagonists, Alice and Bob. They want to share a secret key to start their communication. Okay. So Alice have a source of generating photons. Each photon is generated such that it carries information about its bases. So bases are just the arrangement of photons, basically, because photons can be in excited state and ground state, right? Which is we have all studied in plus two. I hope this is I mean, I hope you appreciate this. And yes, Alice, yeah, there are like basis is kind of arrangement that a photon have when produced. Okay, there are four kinds of bases. What we have seen in block sphere is like there are total six bases, but for the sake of easy, I mean, for the sake of easiness, I will describe at this stage of presentation. I will only describe four bases, that is 0, 1, plus, and minus. 0 and 1 are the deterministic one, which are equivalent to classical 0, 1, and the plus minus are actually the superposition states. That is, plus is the state where quantum bit is in plus 45 degree with the x axis, and minus is when the quantum particle is in superposition with the plus 135 degree from x-axis. Okay, so this is like there are four bases, 0, 1, plus and minus. The two are along the x-axis and y-axis, and are often noted as 0, 1 for horizontal and vertical. The other two are polarizations, that is 45 degree and 135 degree, and denoted as plus and minus respectively. Okay, so yeah. So now please allow me to share my screen so that I can explain addition to. I mean, I can explain this protocol in a better way. Along with that, I will show you my analysis with some addition to the attacker's advantage. My work is not yet verified. However, I started playing with probabilities to find out the real quantum advantage and attacker's advantage. Okay. Okay, before that, let's first appreciate this animation, and then I will share the screen. This animation is from Center of Quantum Technology, National University of Singapore. Okay. Yeah. So after this animation, let me allow. I mean, please allow me to share the screen of my notepad. Hold on.
Okay, guys, sorry for the interruption. My internet connection went down during the presentation, so hereby giving it another shot to complete the work I did. Please bear with me. Thank you. And so let's start. So, what Alice have is that A and B with like with 0 and 1 as the bits, and which are chosen randomly. Okay, and these are the actually control bits for NOT gate and Hadamard gate. What like this is what Alice will use for the communication with Bob. Okay, and this is the part of actually BB84 protocol what they have mentioned in the paper in 1984. So this is like uh, one of the gate is chosen randomly, and what are the four possibilities we have is like I have mentioned here. Let us draw the table for it. Okay, so in the table it will be cleared how bits are chosen randomly, and how resultant output is produced. Okay, so the resultant output yes. Yes. So the resultant output will be like we will name it as psi, and A, B, and psi. This is our output, and with choosing random A and B, we have psi as an output. So now what will be done is like we have before 0 0 we don't have any gate applied, so it will produce same result again. For like only applying Hadamard gate, it will create a superposition of it, right? So for superposition we denote it with plus, because we are in the state 0 initially, and from state 1 if we create a superposition we get minus. Okay, that we have already seen in Hadamard working in previous slides. So yes, this is how we generate a table, and now what Alice will do is like this. Alice will send one of of course one of this four states will be chosen randomly by the Alice, and then it is transferred communicated to Bob. What Bob will do is like Bob will have one basis, random basis already with him, like because of applying Hadamard gate. Hadamard gate will be controlled by that basis 0 and 1 randomly chosen, and once basis is chosen, on depending on 0 or 1, either 0 it will not be used, the Hadamard gate, and for 1 Hadamard gate will be used. Okay, and the resultant will be A dash, what Bob will observe, and this B dash is actually the random bit that Bob have, and B is the communicated random basis that Alice had, which is communicated over classical channel. So this has to be done, and this is nothing to do with Eve. Even Eve will intercept the random basis, she will not get anything. She will not get anything about the bit actual bit chosen by Alice. Okay, so let us create a table with three states, with actually 8 individual states. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 and 1 1 1 finally, right? And yes, so finally psi dash will be the A dash value, what is observed by Bob, and this will be like depending on 0 0 0 we will not have anything applying on the communication channel, so it will be 0. Same way applying Hadamard and Hadamard we will get 0. And yes, same way, similarly 1 minus minus and 1 will be generated. So these are the 8 states which we got finally, and one of the states will be actually observed by Bob. And yes, the condition is that the B dash should equal to B. Then only the communication will be successful, right? I mean the random basis should be equal to the Alice. That is, the Bob's basis should be equal to the Alice basis. Then only we will consider it as a valid bit. Otherwise the bits are discarded. So the discarded bits will be like plus plus and minus minus. So luckily we are getting this observation that like all the superposition states are getting discarded here, right? Because all that Bob wants is like not superposition states. All that Bob wants is the classical equivalent of the qubits, that is 0 or 1. So this is how it will work, and Bob will choose from 0 0 or 1 1. And yes, now what we will do is like B dash and B are actually communicated over a classical channel, where like Bob and Alice can communicate over a simple wired phone call. They can agree their basis, and for the agreed basis, Bob will keep the bits which have same basis, and discard those bits which have different bases. Okay. So B dash is actually a basis. What we are actually denoting here with controlling Hadamard gate. So this is done by a classical channel. This B dash equal to is not equal to B, and B dash equal to B. B dash equal to B or B dash not equal to B is done via classical channel. Okay, this is confirmed by a classical channel. And let us have a simple observation that can be done, like when B dash equal to B. Have a simple observation can be done. Simple observation can be done is when B dash equal to B, we get final value, that is A, which is equivalent to psi dash, right? So that is psi dash is A, right? This is what we wanted for preserving the final bit, as which is a part of final key, right? So for B dash equal to B, yes, for B dash equal to B means that filters with Bob B dash are luckily equal to the filters by basis by Alice. Okay, so that is when B dash equal to B, we mean that like Alice and Bob must have chosen same basis, though they have chosen random basis, but luckily they are equal with Alice and Bob both. So with this setting, let's introduce now Eve. Let's add the component of Eve here. So so yes, so with this setting, let's introduce Eve. We let Eve so I'm trying to explain is like what when B dash equal to B and B dash not equal to B, we are deciding how the final bits are actually generated. And in the table also we have got that for only classical equivalents only, we are luckily getting B dash equal to B, and rest all the B dash not equal to B's are discarded, which is plus plus and minus minus, which are actually the superposition states. This is the in simpler words, we discard superposition states, and we accept classical equivalents, that is 0 and 1, which will be the part of key further. So with this setting, let's introduce Eve. and we let Eve to get 50% advantage. Okay, that is Eve can detect Eve can detect classical 0 and classical 1 without collapsing. So that is when Eve chooses standard basis. So earlier we started with our discussion with the two types of bases, right? Like when the meeting was not stopped in the classroom, we started with two bases, right? Like and rectilinear basis and diagonal basis. So here the picture comes the role of the bases comes into play, like if if Alice, I mean if Bob, if eavesdropper or if attacker chooses different bases than the bases which Alice had used, then it will get collapsed. Okay, Eve can detect classical 0 and classical 1 without collapsing it when chosen standard basis. Okay, so that is by Heisenberg uncertainty principle, only 50% of the times Eve can detect the bits. That is when 0 and 1 are communicated, otherwise it will be caught. Like in simpler words, 0 and 1 are allowed for standard basis, and plus and minus are not allowed for standard basis. They are from rectilinear basis. We have already discussed that they have 45-degree and 135-degree transformations, right? Yes. So again, we want that, like by Heisenberg uncertainty principle, only 50% of the times Eve can detect the bits when 0 and 1 are communicated, otherwise it will be caught. And it will be done only by rectilinear basis. If 0 and 1 are actually observed with diagonal basis, then it will get discarded. That is, it will get caught, right? And Bob will say that these are not equal, and in fact Bob has received the superposition state. So so that Bob will tell that there is an eavesdropper in the in the channel. So only plus and minus are discarded. So let us look into this observation that again that we have A and B as controlling bits from Alice side, and what she transfer Alice transfers is psi. Psi is the resultant of the gates, and resultant of the gates are which we have already seen 0, 1, that is plus 1 and minus. Okay, so for 0 and 1 as psi, Eve can measure with standard basis plus and minus. That is completely fine. This will not get observed by any any of the any of the protagonists, that is Alice and Bob. And it will be only revealed when Alice chooses different bases. Okay, so we actually examine that somewhere in the favorable conditions, Eve, for favorable conditions as attacker's side, Eve chooses the standard basis, and all the bases what Alice had chosen were also standard bases. So then Eve can actually intercept between Alice and Bob without any revealing of the identity of Eve. That is, she will get 100% advantage if all the bases of Eve and Alice are same. Okay, and yes, for diagonal basis, let me rephrase it in a simpler words, like it will get clear for I mean, yes. So what we want to say is like for diagonal basis, plus and minus will not get detected, because plus will be 45 plus 45 degree and minus will be plus 135 degree, and for diagonal basis also we have same 45 and 135 degrees with respect to x-axis, okay, in the block sphere. And same for rectilinear basis, 1 and 0 are not detected. Recall the rectilinear and diagonal basis we have started our discussion with, okay. That is yes, so that is for 0 and 1 we will use rectilinear basis, in which attacker will try to use the rectilinear basis so that she does not get caught in 0 and 1 case. And for plus and minus, attacker should try to use diagonal basis so that she does not get caught. In other words, yes, for 0 and 1, if attacker uses rectilinear basis, she will not get caught, okay. And for plus and minus, if attacker uses rectilinear basis, diagonal basis, then she will not get caught, and vice versa, of course. Like if attacker uses 0 rectilinear basis, she will absolutely able to measure 0 and 1 in rectilinear basis. But for 1 and minus, for plus and minus, attacker will collapse the superposition of the plus and minus states, and it will be converted to uh, classical equivalents. And these are the diagonal and rectilinear bases which we discussed earlier, right? Yes, so that's why we want to make a claim that attacker always have 50% advantage in hand, right? As we have already seen this in the table 1, that whatever be the case, that is whatever be the basis that eavesdropper chooses, she will able to always intercept 50% of the times. That is 50% of the bits will always get known by the attacker, and only the plus and minus are collapsed. But we will also claim that it is not 50%, it is 75% advantage in further part of the presentation. Yes. So let us start a game that eavesdropper comes into picture. Alice starts with A and A0, A equal to 0, and that is B is 1. That is we are considering a case where A is 0 and B is 1. That is Hadamard gate is applied and poly X gate is not applied. Then we get psi is equal to plus, and with psi is equal to plus, we transfer to Bob, and eavesdropper intercepts and tries to measure this plus state, right? And this plus state is measured in standard basis. This is where Alice will Bob will get to know that somewhere it is getting intercepted by Eve, because Bob should not have received any superposition state. With Bob will of course use B dash equal to 1, which was communicated over classical channel. Or even afterwards also there can be a case where B dash equal to 1 and Bob measures it as plus, and psi equal plus. Here what we can observe is like we started with A is equal to 0, but we are ending with Bob is ending with plus. That is a superposition state, right? This should not be the case, because for let us say A dash equal to plus and A is equal to 0 and B is equal to 1, B dash equal to 1, which we have already decided. So this should not be the case that for B dash equal to B, A dash equal to A is always satisfied. But here we are getting that Bob is getting A, I mean Bob is getting plus, and the what qubit was transferred was 0, so that the Bob will announce that, or Bob will broadcast to Alice that the channel is not secure and we need to move to another channel because this channel is no more secure. So what can be done in that case? Like what Bob can do is, like, first is large keys can be created, and second is like multiple time key agreement can be done, like agree and disagree for the multiple keys. This can be done like you choose a random digit from the large key and check whether for 25 digit is agreeing or 76th digit is agreeing. You can do that. And there can also be a possibility where Bob can Bob and Alice together can bear how much noise they can bear, right? So how much noise they can they can cope up with in producing final key. There will always be some random noise also that can be added in with the environment. So now we will start with 50%, the claim that 50% is actually 70% advantage. It is not 50%. So let me draw the table again. Table 1 I am drawing again. So now I want to make a claim that it is not 50%, it is actually 75%. How it is, let me discuss that. So that we know that for standard, assume that Bob uses standard basis, okay, and eavesdropper also uses standard basis, and Alice also uses standard basis, okay. Eavesdropper chooses standard basis, yes, correct. So for standard basis, 1 and 0 are of yes, standard basis is actually rectilinear basis, and 0 1 will remain undetected because in 0 and 1 are 0 degree and 90 degree for rectilinear basis. However, plus and minus are getting collapsed when thrown to standard basis or rectilinear basis. Now assume that 0 and 1 are already passed, okay, that is 50% advantage Eve is already getting. That is 0 and 1 are remain undetected by Alice and Bob, and more precisely it will be Bob. That is Bob does not detect anything about 0 and 1 because Alice had used Eve has used standard basis, right? However, for the other case, plus and minus, we know that 0 and 1 are for 50%, but for plus and minus also there is a possibility that it can be 0 or 1 only, right? We don't want that, we want, it is publicly known that the final bit will be 0 and 1 with Alice, Eve, and Bob. It is already known. With a person who knows quantum mechanics will know that the final key that will be settled with will be 0 and 1. But now we know that there will be chance, like attacker have 75% advantage, that is 3 by 4, okay. For n trials we are looking for, like we will look for n trials now. So here yes, here 0 and 1 are, yes, 0 and 1 are already passed, and plus and minus will be actually we want to make a claim that plus and minus are actually 70 are nothing but only 1 or 0, right? Because final bit will be 0 and 1 only from one of one of the 0 or 1 only that Bob will settle with for the final key. So that is, we want to make a claim that this is a 75% advantage. Two advantages are for 0 and 1, and one advantage is already known that for plus and minus there will be 0 and 1 only. So that PD plus PE is 1, and PD is the probability of detection, and PE is probability of Eve getting succeeded. So this is how the calculations are working. That is PD is 1 minus 3 by 4, and for n significantly large, that is multiple trials with n being very very large, we will get 3 by 4 times to the power n will be very small, and thus probability of detection will be very high. because we want to carry multiple trials, right? Thank you. So from here we left, and let's continue from here. This is what I told you about the basis and how bits are getting equal, like from Alice and Bob's perspective. And this is actually a example from the main paper from 1984 by BB, that is Brassard et al. And this is what I did as a part of project in Python using Qiskit library in Google Colab runtime. And here you can see that the bits are getting discarded, right? uh, Here you can see that the bits are getting discarded where the bases are not matched actually. So this is pretty simple implementation where I did as iterating over the bases, so that final keys are actually generated in on which Alice and Bob are agreed upon. Here there is no component of Eve, and I will try to add the component of Eve in next presentation. And yes, so this is what the recently we have heard about the DRDO and ISRO getting started with this quantum key distribution, which China has already did in 2016, also known as quantum experiments at space scale. We have achieved only 300 meters of quantum communication, while China has already completed their space scale quantum communication project, which they have called as MICUS, MICIUS. And the experiment is important to conduct satellite based quantum communication. So this was already done. These are the primary references what I have used for the project, and these are the secondary references. And in next presentation I will present B92 protocol, Icut's protocol, and I will also present popular attack, photon splitting attack. And I will try to add the component of that is eavesdropper in my code, so that we can actually simulate the real life example, how Alice and Bob communicate in the presence of Eve and they agree upon a key. Because till now what discussed was like the bits are getting discarded because of the only Alice and Bob's basis. But now let's introduce Eve also in the next presentation. I will do that. And that's all.